Hey, what's up, guys? Today we're continuing 5.5. We're doing part 2 and we're expanding logs. So we're going to use the same log properties that we're looking at earlier, but we're going to use them to write these logs. So notice they're a single log. It's log base something, and then we have our expression next to it. We're going to take those and write them as multiple logs. So the first example says write log base a parentheses x square root x squared plus 1. X is greater than 0. So this is just part of our domain restriction, right? So they're just telling us that x has got to be greater than 0 because wait, this doesn't make sense. It's got to be greater than 1. That's a typo. Let's erase that. Actually, we'll just leave it. It's messed up, but if we get into it, it's going to make this even more weird. So just remember, this one doesn't mean anything. They're just trying to domain restriction. We're just looking at this first part here. So we're going to write it as a sum of logs. So remember, anytime we have a multiplication, which we do here, we have x times the square root of x squared plus 1. We can rewrite that. So we're going to write log base a of x, right? And then we're going to write an addition, and we're going to separate it. We're going to write another log based a, and we're going to do it the second part, the square root of x squared plus 1. Okay, and they want us to simplify this as much as possible. So anytime we have a square root, remember we can write any root and power, right? So let's say we have a to the, I don't know, x over... maybe x is not a good choice of words. Let's do m over n. All right, so top represents the power, and the bottom represents the root. So if we look at this one here, right, we have a root which is 2. Square root is 2. There's no power on there. There's a power on the x squared, but not over the overall inside of that, the overall inside of this square root. So it's power 1. So what we can do is say that we have x squared plus 1. We just said the power is 1, right? Because there's no exponent on that whole inside. So 1 over, and the root is 2. So if that were a cube root, the bottom would be 3. If that were a fourth root, the bottom would be 4, and so forth. Okay, and then we're going to do one last thing, and that is anytime, and this is good to remember, anytime we have an exponent with a log, we can take it and drop it in front, right? That was one of our properties that we talked about, and really it's one of the most major ones, because when we get into solving, this property allows you to get to the exponent in the variable in the exponent, and there's no really other way that we can do that. So it's good. This is a good property to remember and always like keep in the back of your mind when we're solving problems. So we're going to rewrite this. Log base a of x plus the 1/2 comes down in front. Log base a x squared plus 1. Okay. So we're going to be using these same ideas. This time we have ln x squared over x minus 1 cubed. Again, this x is greater than 1 is just domain restriction. We want to write it as a difference, right? Because if we divide, we can write that with a minus sign from our properties. So let's go ahead. So we're going to do ln x squared, right? Then we have the division, so we're going to write minus ln again, and then we're going to write the bottom part, x minus 1 cubed. Right, we have these exponents again. So at this point, we can take those and drop those in front of the ln. So we have 2 ln x minus 3 ln x minus 1. Right, and then once we've done that, we're good. Okay, on to the last one. So this one's got multiple parts, right? So we have two things in our denominator, and then we have this square root in our numerator. So let's go ahead and apply the same thinking again. So we're going to write the first thing, log base a of the top. And then because x cubed is in the denominator, we're going to minus log base a of x cubed. And then we have one more thing in the denominator, so we're subtracting that too. We have x plus 1. Oops, sorry, I forgot my log. Log base a x plus 1 to the fourth. Okay, if you need this next step, we're going to convert this square root again, right? So log base a, we're putting in parentheses the inside x squared plus 1, and then it's going to be power 1, right? There's no exponent on the inside, the whole inside, and then the root again is square root, so we're putting that underneath our exponential, our rational exponential, or our, yeah, I guess you would call it that, right? Because it's a fraction in the exponent. The rest is the same. Well, actually, we don't even have to. Yeah, okay. The rest is the same. Okay, and then we're going to take all our exponents now and then bring them in front of our log. So we have 1/2 log base a of x squared plus 1 minus 3 log base a of x minus 4 log base a of x plus 1. Okay, and then now we're finished. All right, so again, if you're good at that, recognizing the power root thing, then we can probably skip that step and just drop all of our exponents down all in one step, whichever is easier for you. The more you work on it, the better you get at recognizing what you can do and what you can't do and making things simpler. All right, but that's it for today. Good job.